Okay, this is a network. Notice then. Okay, 3 voltage sources. This is the given as 2 ohm, 4 ohm, 6, 2, 4, 6. Then this is 8 volts, 6 volts, 12 volts. They given this one loop current IL1 means this is a loop 1. This is loop current IL2 means loop 2. This is IL3 means total how many loops are there? Yes, 3 loops are there. Fine. Now we need to draw a oriented graph for this network. This is a network given. We need to draw a oriented graph for this network. Yeah. Now just see here. If I'm going to take this is one node, this is one node, this is one node, and this is one more node. Okay. Now first I will write these nodes 1, 2, 3, and 4 nodes. Okay. 4 ohm. We are going to replace this one with a short line. This one online, and hold this 6 to 12 volt here. This is one, this whole 6 to 12 is there. This is one branch 1. Okay, and this is 4 to 6 volt. This is one another branch. This is branch 2. Okay, and this is 2 and volt 8 volt, one branch. This is one branch. Fine. Now this is branch 3, node 1, node 2, node 3, node 4. Okay, and this one is one branch 2 to 4. Okay, 1 2 3, then 4 5 6, 4 5 6. Yeah. Tell me how many nodes are there?
4,
4 nodes. How many branches are there?
6,
6 branches. Okay. Now for, see here, we need to know from this linear graph, linear oriented graph, number of possible trees. See, anyhow, I am going to give this one in a MSc 1. Number of possible trees. How we are going to calculate number of possible trees from this graph? This is not related to this problem, but I am explaining how we are going to calculate number of possible trees from this graph. First class in a network, we have studied about this. That is, first we need to calculate the integer matrix, then multiplication with that transpose of that instant matrix, that is number of possible trees. You go and check the videos, you will get to know A into A transpose is nothing but number of possible trees. Okay. This is not our concern here. Okay, now after drawing the up, we have to give some orientations, right? Giving like this. No. For the network shown, write down the Tysett matrix and obtain the network equilibrium equation in matrix form using KVL. Okay, then calculate the loop currents. Fine. First, for writing the Tysett equation, first we need to write a tree. I am going to select tree 4, 5, 6. Tree is nothing but it has to include all the nodes. Okay, now I am considering tree 4, 5, 6. This is 1, 2, 3, 4. All the nodes are covered. This is my tree. For writing Tysett matrix, first we need to consider any one of the tree. I am considering this tree, that is the tree with branch 4, 5, 6. Fine. Now tell me what we are going to call those branches of a tree.
Twigs.
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 Okay. For MSc 1, part A and part B is there. For part A, some objective MCQ will be there. Okay. For 10 marks, 10 questions, 10 minutes. Okay. Part B, 20 marks. 3 questions will be there. Any 2. Fine. Here. Now, okay. The branches of a tree will be called as the twigs. Now, next step, we need to draw a links.
Links.
Link 3, 1, 2. Yes. Now tell me from this graph, links. What are the links?
1, 2, 3.
1, 2, 3 other links. Yes. For writing the Tysett matrix, how are you going to write? Anyone explain? First, I will explain for one. If I am going to replace this link 1, it has to form a closed loop. So I am going to write first link 1 as 1, 4, 6. 1, 4, 6. This is my link 1 because I have to replace 1, 4, 6. After replacing 1, I am forming a closed loop here 1, 4, 6. Right. Then link 2. Tell me if I am replacing link 2, 2,
5,
5,
6.
6.
6.
Yes. Then link 3. This one. 3,
3, 4, 5.
4,
3,
5.
4, 5. Okay. Now we know I'm going to replace write the Tysett matrix capital B. My rows will be a links. Then columns will be my branches. So my links will be 1, 2, 3. How many branches are there? 6 branches. 1, 2, 3, 4, 5, 6 branches are there. Now tell me for link 1, 1, 4, 6. See, for link 1, 1, 4, 6. That link with the the direction of the link. It means whenever we are going to replace link in a tree, it has to form a closed loop. Then the direction or orientation given by that link itself. So link direction, one direction and branch direction one is same, so +1. Okay, and in a link 1, 2 is not there, 3 is not there, so 0 0.
0.
In link 1, 4 is there, 4 is in the same
Plus
direction, so +1. 5 is not there, 0. 6 is
1.
same direction, 1. Okay, coming to link 2, 2 5 6. See, 2 5 6 are there, so I am going to write 1 is 0, 3 is 0, 4 is 0. Okay, for 2,
1.
for 2 is 1,
1.
for 5 is
-1.
5 is +1.
5 is 1, sir.
5 is
5
+1.
is
See
1.
here. Yeah, 5
6
is
is
1,
-1.
6 is -1. Yeah. Coming to link 3.
Sir,
Yeah.
in
Tell me.
oriented graph, link to is direction thing.
Yeah, see here, link 2 direction is like this.
Oh, yes, sir.
Correct, na?
Yes.
Link 2 direction and this twig 5 direction is same. See here.
Yes, sir. Yes, sir. Yes.
Okay. And coming to link 3, 3 4 5 are there, so 1 is 0, 2 is 0, 3 is 1. Always whatever the link number is there, that is +1. Okay, then 4, 4 is opposite, 5 is also opposite, correct? See here, this is in this direction, 5 is opposite, 4 is opposite, so -1 -1. Then 6 is
0.
0. This is my dissect matrix. Dissect matrix. Okay, now what they told, the KVL equation in matrix form. We have to write the network equilibrium equation in the matrix form using KVL. Okay, now we got this. 1 minute, I will delete this. Yeah. Okay. The KVL equation in the matrix form is given by B ZB B transpose IL, then B into Vs minus B ZB IS. Fine. Here this network is visible, right?
Yes, sir.
Yes, sir.
Yeah. Here there is no current source. Okay. So IS is 0. How I write this equation, KVL equation? If you go to the last class videos, you will get to know. Because in the basic KVL equations, okay, how we are going to write the equilibrium equation for that network will be explained there. Okay, here I will get, if IS is equal ZB B transfers IL B Vs. Vs is the source voltage vector, B is the dissect matrix, B transpose is the transpose of that matrix, ZB is the branch impedance matrix, IL is the loop current matrix. Okay, this is my KVL equation. Now I need to write ZB. Now how am I going to write ZB? ZB is the diagonal matrix. How many branches are there?
6.
6 branches in the sense ZB will be my 6 into 6 square matrix. Okay. Here Z11, Z22, Z33, Z44, Z55, Z66. Rest all 0. Okay. My ZB is the diagonal matrix of branch into branch, means 6 into 6. Okay. Now see here, I can write Z11. Tell me Z11. Yes. See the network and tell me.
6.
6. Because in that branch the impedance is 6 ohm. Okay. I can write here Z11 6. Then rest 2, 3, 4, 5, 6. Then this one is 0. Branch 2.
4.
4. Rest 0. Branch 3.
2.
2. 0, 0, 0. Branch 4. 4 ohm. Branch 5. 6 ohm. Branch 6. 2 ohm. See here, this is branch 1, this is branch 2, this is branch 3, this is 4, this is 5, this is 6. Okay.
Sir, for branch 4, shouldn't it be like in 4 should be in the 4th position?
This is 4. 4, 0. This is 6, 0. Yes. 6, 4, 2, 4, 6, 2. Okay. My ZB is the square matrix, 6 into 6. Diagonal matrix. Fine. Now B transpose means return ZB, then B transpose, just a transpose of that. Okay. Then IL. First I'll write B transpose. Yeah. 1 0 0. Yeah, tell me fast. 0 1 0. 0 0 1.
0, 0, 1.
1 0
1,
minus
0,
1.
minus
0 1 minus 1.
0.
1 minus 1 0. Okay, this is my B transpose. Okay. We need to calculate IL. Okay, I can write IL equals to how many loops are there?
3 loop.
3. IL1, IL2, IL3. This is my IL. Okay. Now VS. VS is a column matrix. Okay. Here I can write VS1, VS2, VS3, VS4, VS5, VS6. This is my VS. See the network and tell me what are the values for this. VS1, branch 1,
1.
source voltage 12. Then VS2, branch 1, branch 2, source voltage -6. Why? Because see, we are seeing from this. This is my path. 1, 2, 3. Okay. -6. Then VS3, see, -2 plus 8. -8, 0, 0, 0. 1, 2, 3, 4, 5, 6. See, this is my VS vector. This is a column vector. This is my IL. IL1, IL2, IL3. There are 3 loops. This may ZB diagonal vector. Okay, B transpose. We now see written this VS B IL B transpose ZB B. Okay, now we need to calculate. 1 minute. Okay, we need to calculate B P ZB B transpose equals to we need to calculate this one. Okay, we already written this. Okay, you calculate this one. Fine. Means my final also will be like this. 12 minus 2 minus 4 minus 2 12 minus 6 minus 4 minus 6 12. You know the vector multiplication, right? How
Yes.
to do the multiplication and all, right? IL1
Yes.
IL2 IL3 equals to my source 12 minus 6 minus 8. This is I am going to get at the final stage after multiplying all the vectors. Now simply I can calculate from this IL1 equals to IL2 equals to IL3. Fine. For reaching this stage, we need to know how to write trisect matrix, how to write impedance matrix, and how to write loop current matrix and source voltage matrix. If you set impedance, loop current, source voltage matrix, then we'll reach up to this point. Then simple, we going to calculate IL1, IL2, IL3. Fine. Okay.
Yes.
Yeah.
Yes.
We'll go to this one. Duality. What do you mean by duality? Duality. Yes. If two networks are said to be the dual of each other, when the mesh equation of one network are the same as the node equation of other. It means what? Here definition of duality says that if one network mesh equation equals to the other network node equations. Yes, equation is equal to node equation. Yeah, it means what? KVL equals to KCL, right? Right or not? Means dual in the sense what? Here in a network, how we are going to say? If incidence matrix of one network is equal to cut set circuit matrix of the other network. If two networks are said to be dual of each other, then one network mesh equation is equals to another network node equations. That is nothing but the KVL equations of one network is equals to KCL equation of other network. Okay, then coming to if a matrix, this one here, if I am going to write the incident matrix for first network, that should be equals to the circuit matrix of the other network, dual network. So simple. Here we can see loop. How see loop analysis and node analysis. This is first network. This is my second network. I can say these are dual networks. Okay. Now, if current source is here in the first network, I am going to replace that with the voltage source. Then coming to this in loop, resistance is there. Then reciprocal of resistance. What is the reciprocal of resistance?
Resistivity.
Conductance. Conductance. Who told resistivity?
Yes, ठीक है.
See, current will be replaced by voltage source, resistance will be replaced by conductance. Then inductance will be replaced by capacitance. Okay. Then branch current will be replaced by branch voltage. Okay. Then mesh analysis will be replaced by node analysis. Here only we said node. Then short circuit is there. It will be replaced by open circuit. Then parallel path will be replaced by series path. See, what do you mean by dual? How we are going to write the dual network? If two networks are said to be dual, in the sense first network mesh equations will be equal to the means similar to the second network node equations. That means the KVL equation of first network will be same as the KCL equations of second network. In the network form, I can say incident matrix of first network will be the same as the circuit matrix of the second network. Then I am going to say those networks are dual in the nature. Duality, dual networks. So a simple table form I can write. If in first network current source is there, how we are going to write the dual of that? Current source will be replaced by voltage source, resistance is replaced by conductance, inductance is replaced by capacitance, branch current is replaced by branch voltage, mesh will be replaced by node, short circuit will be replaced by open circuit, then the parallel path will be replaced by the series path. So we can write the dual of that network. Fine. Now there are some steps are there. For understanding those steps, we need to go through on a simple example first. Now this is a network. See here. 1 minute. Yeah. This is a network. This is capacitor. This is inductance. Yeah, this is voltage source. Then one more resistance. Fine. R1, C, L. This is R2. This is V. According to that table, this one will be replaced by
Conductor.
according to the table, see this.
Conductance.
Yeah, this one will be replaced by
Inductance.
Inductor.
this one capacitance, this one conductance, this one is a current source.
Current
Correct?
source.
Current.
Yeah. Here we need to follow some steps. First, what we need to do? We need to place a node inside the loop. See here, I'm going to place node here inside the loop. Okay, then one node outside the loop. This is a simple way. How I understood, I'm telling that's it. Okay, place a node inside the loop. Two nodes I'm going to place in. Two loops are there, so two nodes I'm placing. If three loops are there, three nodes we are going to place. Then one uh, node outside. This is my reference node. This is my base node. This is my datum node. Correct? All three are same: datum node, reference node, base node. Okay. Now connect two internal nodes through a dashed lines. Here I am going to connect this one with a dashed line. These two internal nodes I am going to connect with the dashed lines. Okay, now the elements which is dual of the common branch here is a capacitor. In the sense here this is a common. If I am going to replace L with C, then this is a common for both the loops, right? So now connect all internal nodes to the external node by a dashed line causing all the branches. It means first place the nodes inside the loops and one node outside the loop. Okay, after that connect this reference node huh, to the reference node by crossing the branches like this. Yeah, same here also. Fine. Now you can see develop these branches will form a branches connecting the independent or atom. Oh, fine. Now tell me, this is one node. How I'm going to write this one? This is one node. This is another node. Yeah. L will be replaced by. Tell me, inductance will be replaced by capacitance.
Capacitance.
This is capacitance. This is one node. One. This is second node two. Okay. This is my reference node. Fine. This is my reference node. 0. Datum node, reference node, base node. Okay, fine. Now, C is there here. Now, this crossed by this dash line crossed to this reference node with voltage source, right? I have to replace this voltage source with
Current.
current
Equivalent
source.
Current.
source.
Yes, current source. Fine, then crossed this resistance, conductance. That is G2. R2 will be replaced by G2. Fine, this R2 is replaced by G2. Now, from this node, which is parallel, see, this node is crossing this node. Okay, R1 is parallel right here. See here, R1 is parallel to this node, correct?
Yes.
Now I'm going to write from here G1. I have to replace R1 with G1. Then here from two capacitance is there, right? Parallel. C
Yes,
will be
sir.
replaced with
Inductance, sir.
inductance
L.
Inductance.
L. Simple, right? This is I. Now dual. See, we replace it with I. Correct? R1 replaced with G1. R2 is replaced with G2. Okay, L replaced with C, C replaced with L. This is my dual of this network. Simple. What is there? If network is given, if they are going to tell ask to write the dual of this network, then what we need to do first? Place the node inside the loops and one reference node outside. If I am having, see here, if I am having, okay, if I am having 3 loops, I am going to place 3 nodes, one reference node. First I am going to connect inside loops with dashed line, then reference node with crossing the branches. Okay, like this. Here also same. Place the node inside the loops, one reference node outside the loop, then connect those inside nodes with a dashed line, then connect these nodes crossing the branches with the reference node, then write the develop the network. Yeah, understood, right? ಅರ್ಥ
Yes,
ಆಯ್ತಾ?
yes, sir.
Okay, I'll take the attendance. Wait.